Are you familiar with this? These are equations but in different forms. This equation is in standard form, general form, slope-intercept form, intercept form, two-point form, and point-slope form. Today, I will teach you these different forms, but before we start, what is a linear equation? Linear equation is an equation between two variables that gives a straight line when plotted on a graph. Types of forms: the standard form, general form, slope-intercept form, intercept form, two-point form, and point-slope form. Let's start with slope-intercept form. So the formula for slope-intercept is y is equal to mx plus b, where m is the slope and b is the y-intercept. If we need to find the slope, the formula is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. For example, y is equal to 5x plus 3. If we follow the formula, the slope is 5 and the y-intercept is 3. We also know that m is equal to rise over run, so if we plot the slope, it will be m is equal to 5 over 1. The second form is intercept form. The formula is x over a plus y over b is equal to 1, wherein a is equal to x-intercept and b is equal to y-intercept. Always remember that intercept form is always equal to 1. To turn the intercept form into standard form, get the LCD, then multiply both sides. Let's move on to two-point form. The formula for two-point form is y minus y sub 1 equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times x minus x sub 1. Actually, two-point form and point-slope form are connected because if we compute the two-point form, its answer will be point-slope form, which is y minus y sub 1 equals m times x minus x sub 1. For example, 5 and negative 2, 4 and negative 7. Let's substitute the points. Y minus negative 2 equals negative 7 minus negative 2 over 4 minus 5 times x minus 5. Let's simplify the signs. Y plus 2 equals 5 times x minus 1. Now let's simplify it to standard form. Distribute the slope, which is 5 to the right, so it will be y plus 2 equals 5x minus 25.
So now we will be talking about the angle of inclination. So let's say we have this line. and let's plot it right here. And so we have this line. So we are going to find this angle right here, and we will call it angle theta. So this, as we can see, we can make into a triangle. So let's construct a line right here. So now it's a triangle. So we know that in trigonometry, there's this thing called SOHCAHTOA, wherein sin equals opposite over hypotenuse, cos equals adjacent over hypotenuse, and tan equals opposite over adjacent. So in this triangle, we don't exactly have a hypotenuse. So what we can use is only the opposite and the adjacent. So we are going to use tangent. So tangent equals opposite over adjacent. So you can say that tangent theta is equals to opposite over adjacent, right? So when we look at this angle right here, we can see that this line that we constructed is the opposite. And what is it in this line? It is the rise of the line. So rise. And the adjacent is this one, because we can use this is the hypotenuse. And this is the run. Isn't this formula familiar? This is equals to the slope. So now we get the formula for angle of inclination, which is tangent theta equals slope.
So here's an example of the angle of inclination. So since we know that you only need to get the slope, so just substitute the values of the points for the slope formula. And now you will get the slope, and then just use the arctangent in your calculator to get the degrees. And since our example is a negative, just add 180. So here is the answer that we will get.
So now we will be talking about the angles between two lines. But first we need to derive the formula. So in this figure, we are finding the angle theta, which is the angle between the two lines. And angle beta and angle alpha serves as the angle of inclination of the two lines. So we can see that angle beta, first of all, this forms a triangle, and angle beta is an exterior angle. And we know that the sum of the two remote interior angles is equal to the exterior angle. So we know that beta is equals to alpha plus theta. And by transposition, we can get theta equals beta minus alpha. And so if tangent theta is equals to tangent beta minus alpha. And from this, we can see that 1 is kind of the same as the trigonometric identity, which is tangent A minus B equals tangent A minus tangent B equals 1 plus tangent A times tangent B. So if we are going to substitute it now, we can get tangent beta minus tangent alpha over 1 plus tangent beta times tangent alpha. And from the previous lessons, we know that the angle of inclination is actually the slope. So again, we can substitute it to make it a simpler formula. Which is m sub 2 minus m sub 1. This line is m2, this one is m1. So m2 minus m sub 2 minus m sub 1 over 1 plus m sub 2 times m sub 1. So since we know that tangent beta minus alpha is also equal to tangent theta, now we can say that tangent theta is equals to m sub 2 minus m sub 1 over 1 plus m sub 2 times m sub 1. So now we found the formula for the angle between two lines.
So here's now an example of the angle between two lines, and you can see that we already have two slopes. So all you need to do is substitute those slopes to the formula, and then we can get the answer, which is 1 over 8. And then use the arctangent in your calculator to get the degrees of the angle. So now let's try to find the angles of a triangle. So first we need to get the slopes of the three lines. So here we're getting line 1, and we got 5 over 3. And now we're getting line 2, and here is the slope. It is negative 2. And for line 3, we will get 1/5. So we just need to substitute the values of the lines for the sides of the angle, and here we're getting for the alpha, and we substituted the values for line 1 and line 2. So do the procedure for the angle between two lines, and you will get the degrees of the angle. So we got negative 11 over 7, and just use the arctangent to get the degrees. So it's a negative, so just use the absolute value. So now for tangent beta, we substituted the values for line 3 and line 2. So do the same procedure as you did for the alpha, and you got 11 over 3. So use the arctangent to get the degrees. And now for the tangent theta, and you will use the lines 1 and line 3. Again, use the same procedure. And we got 11 over 10, so use the arctangent to get the degrees. So to check if we got it right, we need to add all of the degrees of the angles, and we should be able to get 180.